Hey, can all you guys hear me? Just checking the audio is working. Wait, it looks like we've got a bit of a small class tonight. Always fun. In that case, we'll get started. Cool. So, carrying on with our electronics topic. Always fun. Got another couple weeks of this, and then we'll do a week on magnetic interference before we move on to revision. Cool. So, one second, guys. So I'll probably delete that from the recording, but I'll be sure to add the link into the video description. Cool. So electronics. So how many of you guys have seen what was that movie where they recreated the cracking of the Enigma machine? One that had Cumberbatch or whatever his name is. Imitation Game, I think it was called. You guys have seen that film. If you guys watch that film, the machine or the computer that he builds all runs off those mechanical switches that were in the first part of the video. That's why it's so loud, and you see the rotating dials going click, 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 click. It all runs off of switches. Whereas the Americans were using vacuum tubes to power their computers to build the atomic bomb. A similar machine was then used by IBM. It was bought by NASA from IBM, and that is the computer in the movie Hidden Numbers. So that's how they got it in space. They used both computers, as in people doing maths, and the IBM machine. So there is a lot we can do with electronics. Yes, it's a bit of a dry topic, but it does have applications. And the fact that we can now do what they were doing with a room-sized computer, we can now do on our phone. And it's only been about, 60 years since they were using computers that big, and we're now using computers the size that fit into our hand. And also, a lot of people nowadays love the vacuum tube for old school amplifiers because they believe it sounds a bit purer. So occasionally you will have to, some people do ask you to replace vacuum tubes. So tonight we'll start looking at power diodes, thyristors, MOSFETs, and IGBTs. So semiconductors, they're often used as a switching device. This allows contactless switching of currents from a few milliamps to several hundred amps. and the voltages range from a few volts to several megavolts DC. Such a device is called a power device. When the device is part of an integrated circuit, the IC is called a power IC. The power semiconductors are usually used in commutation mode, either fully on or fully off. Such semis are optimized for this application, semiconductors, and will not perform well in a linear circuit, such as a voltage regulator or audio amplifier. Cool. So this is what we call a bipolar junction transistor, or a BJT. It's available in NPN and PNP versions. So to bias in NPN, the base must be pulled high. To bias in PNP, the base must be pulled low. So you can only tell the difference between when we have the symbol. So at NPN, we'll have the arrow pointing towards the emitter. And for at PNP, it'll be towards the base and away from the emitter. So NPN, high away from the base, low, PNP, towards the base. So that is how you tell the difference in a circuit. So small base currents allow large collector currents to flow. Current flow is proportional to the transistor's gain. However, current is still limited by the load. When an increase in base current no longer results in an increase in load current, the transistor running in commutation mode is running in commutation mode, also known as saturation. Cool. So three-legged device, CBE. So transistor is a three-legged device with a collector, base, and emitter, so CBE. It acts as an amplifier. A small current applied to the base will allow a large current to flow between the collector and the emitter, but never out of the base. Increasing the base current will cause a corresponding increase in collector to emitter current. So it can be used as a simple switch. Large base current is applied to saturate the transistor. Removing the base current turns off the transistor. This allows a 5-volt microcontroller or a small membrane switch to control large currents at differing voltages. So the BJT is cut off with zero base current and is turned on by an increasing base current at a threshold of about 0.7 volts. The graph of base emitter voltage against collector current is called the mutual characteristic or transfer characteristics. Cool. So here you can see the collector current in milliamps, and here is the base or emitter voltages. So as we get towards 0.7 volts, then we start conducting. So we see more current flowing through the collector. So basically it is a switch. It is a small switch which we can mount into a circuit board. So if you think about your light switch, but very, very tiny, or the size of a relay, shrunk down to about the size of a pen cap or smaller. Cool. So electrically, a transistor will look like two diodes back to back. And you've got your field effect transistors. So you've got your junction gate field effect transistor, also referred to as JFET. Insulated gate or MOSFETs. The reason is metal oxide silicon or semiconductor field effect transistors. Both are available in NNP channel versions. So an N channel FET or field effect transistor acts like NPN, and a P channel acts like a PNP. Cool. So you got your N and P channel. So again, So you've got your drain, your source, and your gate. Your source being your supply, your drain going out to your circuit, and the gate either getting high current for the N and the P low. The direction of current flow shown by the arrow. With zero gate bias, the drain to source resistance is low, allowing current to flow. Applying bias to the gate will reduce current flow, kind of like squeezing a hose. So all the FETs that conduct without gate bias are called FETs. All J FETs are depletion FETs. It's a lot of terminology. Realistically, with electronics, the most you're usually going to get asked about diex, triax, normal diodes, and your xenodiodes, power diodes, diex, triax. Might get a few transistor questions, but a lot of this transistor stuff is for kind of more your electrical engineering or when you get into electronics designing. Cool. So yeah. So N-channel depletion and N-channel enhancement. So depletion, it's all connected. Enhancement, or we've put current to it, it's open. So there an improvement on the BJT or bipolar junction transistor technology. Both N and P type semiconductors are used, but a coating of the metal oxide insulator achieves an insulated gate. So this gate has several benefits. So higher power efficiency because we don't have base current flow. As we increase heat, the conductivity decreases. This makes it easier to parallel MOSFETs. If one device tries to conduct more than it should, it will heat up and its current flow reduces. The bipolar junction transistor is the reverse of this. If one overheats, it will conduct even more current, making it overheat more until it eventually fails. So they're better suited for devices which are going to have more heat. So if you guys look at your laptop battery bricks, more than likely your laptop battery bricks will have more MOSFETs in them than BJTs, just because obviously, as you guys know, you charge your laptop battery, your chargers heat up quite a bit. Cool. So they're available in depletion types as well as enhancement types. An enhancement MOSFET initially blocks current flow, allowing more flow as gate bias is increased. So here we have two N-channel MOSFETs. Cool. Then you've got your insulated gate bipolar transistors, or your IGBT. So these are combined and isolated gate FET and BJT in a single packet. So they're used for switching power supplies and motor control applications, so your variable frequency drives or your inverters. So it uses a MOSFET as an input stage due to the simple gate drive and the characteristics and isolation input. And it uses the high current BJT as a switch as an output. Cool. Thyristors. So they're basically silicon-controlled rectifiers, triax and diax. So who's heard of any of these before? Cool. One of the common questions you'll get in your capstone is, what is this? And it'll either be a diac, a triac, a diode, LED, power diode, xenodiode. It's quite common you'll get those questions. Cool. So your silicon-controlled rectifier. So it's a three-legged diode with the ability to control when it begins to conduct. The SCR needs a gate pulse to start conducting. When gate to cathode voltage exceeds a certain threshold, it'll begin to conduct and act like a forward bias diode. So construction stops once current falls below the SER's holding current value and must be triggered again to start conducting. You can see on the board there. So reverse voltage, you get a little bit of leakage current, but then as you get breakover voltage, you get high conducting, so forward current. So it's basically acting like a half wave rectification, like we looked at with the diodes. So it's just a simpler way of doing a little bit of rectification, because only when you put the forward voltage to the anode will it start to conduct to the gate. Cool. So by controlling the point at which the trigger pulse is sent to the SCR gate, it's possible to control the period of conduction of the sine wave. This is known as phase control and is used for motor speed control, temperature limiting, and light dimming. So you'll find these a lot in your dimming. So who can tell me what leading edge and trailing edge dimming is? Because that does come up from time to time. So what is leading and trailing edge dimming? Okay, cool. So these are quite common when it comes to your dimming. Cool. There we go. Cool. So we have our AC sine wave. Okay, go try these. Cool. So when we're talking about leading edge, we're talking about this area in here and here. So what a leading edge dimmer does is it basically chops out this part of the waveform, meaning that you're only left with the back half, but it doesn't do it all at once. It starts maybe about here and then chops out that area there. So that's what a leading edge does. What a trailing edge does is it chops out the second half of the AC waveform. Cool. So who can hazard a guess as to which we would use for LED dimming? Cool. So if we think about the way a capacitor works, a capacitor creates a leading power factor. So it's more than likely we're going to need a leading edge dimmer for our LEDs. But again, you'll still need to check your light fitting. Some will specify whether to use a trailing edge or leading edge dimmer. But they will contain things like silicon-controlled rectifiers for that and capacitors. Oh. It's a little side note there. So some of my pre-traders, when I ask them, basically some of their practical book, ask them about how does a dimmer work, and they say, oh, it's just a resistor, which you would be hard pressed to find any dimmer nowadays that uses a variable resistor. They probably did back when we had filament lamps, but now You do need a leading and trailing edge type dimmer, depending on the type of light. So the next time you go to buy a dimmer, make sure you've checked what kind of light you've got and what it requires. And please go to your tradesman, especially you, Leighton, tomorrow, and ask them what's the difference between a leading and a trailing edge dimmer and see if they can give you the answer. That's good. Cool. Yeah, cool. So triac. Cool. So a triac is equivalent to two silicon controlled rectifiers connected in reverse parallel. So they are basically a bidirectional electronic switch, and they can control current in both directions when triggered. So like an SCR, it can be used to control the entire sine wave rather than just half of it. Cool. So difference between, so variable resistor changes rate at which capacitor charges. When the capacitor is sufficiently charged, the triac's gate is triggered. Gate triggering voltage is reached, turning on the triac. The triac allows control of very large power flows with milliamp control currents. So the phase control or phase cutting is a method of PMW applied to AC voltages. So we're looking here at the variable resistor. It changes the rate at which that capacitor charges. When it's sufficiently charged, the triac's gate triggering voltage is reached, which means it then sends a signal to the triac, which then allows a very large power to flow with just a milliamp control current. So we use them as switches for very large power flows. So this will be inside of a piece of electronic equipment. And then this is the diac. This does come up in capstone. Some of the guys on block course pointed this out in their capstone, and we just hadn't quite covered it in night class yet. It wasn't one of the topics that had come up yet. So it's used to provide a sharp triggering voltage to a triac. Like placing two diodes back to back, there will be no current flow until the forward voltage of the diode is exceeded. This allows voltage to rise across the triggering capacitor before being suddenly allowed to flow to the gate of the triac. So make sure the capacitor is charged first. Yep, we got through that pretty quickly. But now, right one. Oh, it's not. Cool. Cool. So have a go at these questions. I don't care if you use Google. Google is your friend. But have a look through these questions, and then we'll come back in a little bit and we'll just go through some answers. Cool. So who can tell me the purpose of rectification in a linear DC power supply? All good, Liam. See, like I said, don't care if you use Google for this because, yeah, it's fine. We're just doing some practice. Yeah, so basically, just say it's to convert AC to DC. Cool. What about regulation? Just throw a guess out there. It doesn't matter if it's wrong, just have a good guess at it. So you guys have looked at transformers and what regulation is? Yeah, that's what the capacitor is used for. Yeah, but what about regulation? So what is the purpose of regulation? It's not a device, it's just the term regulation. So we'll take the reservoir capacitor, and so it is used for smoothing DC waveform. Yeah. Yeah, so the point of regulation is to keep the voltage at a constant level. Cool. So briefly describe the purpose and construction of a 3-pin rectifier. So what is the purpose of a 3-pin rectifier? Yeah, so the purpose is AC to DC conversion. And the basics of the construction. Basically looks like all the other rectifiers that we have looked at. Cool. Down. Cool. So capacitor filter is always placed in watt with the load, and inductor filter is always placed in watt with the output. Well, sorry, with the output. So just work on these and then we'll come over the answers. I'll just read out the questions. State 2 benefits of switch mode power supplies over linear power supplies. And state 1 benefit of a linear power supply over a switch mode. Cool. And then we have a diagram of fixed series. Don't worry about that. Basically, you would just put a potentiometer in there, I think. All right. Get to these questions in a bit. Just before I walk away and leave the room, got a poll going with my other night class. What's everyone's favorite energy drink? See, most of them were like, they're just YOLO Kyle White Monster. And there were a few that like that Celsius, which is like the healthy one. Okay, cool. So when we're using a capacitor filter, we always place it in watt with the output. Yeah, does everyone else agree? Yeah, so whenever we have a filter capacitor, it's always in parallel. Cool. So an inductor filter is always placed in watt with the output. Yeah, so basically capacitor is the opposite of an inductor. So if we've got an inductor and the capacitor is in parallel, the inductor must be in series. Cool. So give me two benefits of a switch mode power supply over a linear power supply. They're smaller. Yeah, they are compact. So we could say they're compact. Anyone got any others? So just to refresh everyone's memory, your switch mode power supply is one that switches on and off. It's usually used as an inverter style power supply, whereas a linear power supply is like a battery or a power supply that only gives out a continuous voltage or a continuous signal. The linear power supply is basically a transformer. It reduces AC input, then converts it to clean DC. A switch mode power supply uses pulse width modulation to efficiently regulate the output voltage. Cool. So another benefit of your switch mode power supply is they have a higher efficiency. Make sure I'm spelling my shit right. And another one is that they have flexible applications. Cool. So what about linear versus switching? What are the pros to a linear power supply? Yeah, probably more likely cheaper. Has anyone got any other ones? So other than cost, what is another any other ones? So they are simpler. There's one other one. One other quite large probe. Okay, main thing about a linear versus switch mode is they are they're cheaper, simpler, and a heck of a lot quieter. Think about how the switching works. They usually need external cooling fans as well. They tend to spin up a lot more. So the linear power supply are a lot quieter. Oh, so clear that and move down the page. Where are we on this? Cool. Cool. Yep, so we'll just do these two to finish off. So I'll give you a bit of time. More than happy for you guys to use Uncle Google. So yeah, state the main performance benefits of the following types of capacitors: ceramic, mylar, and electrolytic. And then 9, how does a Schottky diode differ to a power diode? Okay, so main performance benefits of a ceramic capacitor. Two parts to the answer. Yep, high voltages. What's the other one? What the frick? Sometimes this pen hand. Also, higher voltages and not really about cost, or the capacitors are mostly small, but there's something to go along with your high voltages, Oliver. Oop. It's a ceramic capacitor. Can handle high voltages, so therefore it must be able to handle high watt. Yep, high heat. Good one, Oliver. Yep, so they can handle higher voltages and heat. Cool. So what about Mylar? There's quite a few of these. I use a different color this time. Cool. Some advantages to a Mylar capacitor. High dielectric. Yeah, so that's what we'd probably talk about capacitance. So, well, so it's a higher, so it's got. Okay. Higher capacitance than ceramic. Anyone got any others? Yeah, so just a heads up, I do have one in-person student. So yeah, so high capacitance, they can be non-polar, which means we can get them in polarized and unpolarized, more than likely non-polarized. Yeah, they're generally pretty, yeah. I'll say they're stable. Most of them are. But yeah, they are stable. I'll just get the rest. So they're basically a good, cheap, general one too many P's there. Capacitor. Cool. So what about a electrolytic? Cool. So I'll give you the first one. They are pretty fucking cheap. Well, you find them in pretty much every piece of electronics you'll open. They look like a cylinder with two legs. High capacitance versus size. Yeah. Cool. High capacitance small form factor. Cool. Yeah, I will note, unfortunately, they are DC only. Cool. So, how does a Schottky diode differ from a power diode? Yep, it is faster. Why is it faster? I'll grab yet another color. I'll just go back to red. Yep, it has so it's not a volt drop. It has because it has a lower, oh, swap pins. Maybe there's this. Oh no, apparently the blue one is an eraser. Yeah. Cool. So it has a lower, so I have to write it a bit higher. Bias. So it has a lower bias voltage. So it doesn't have a lower volt drop. It has a lower bias voltage required. So it can be used in circuits where fractions of a volt matter. Cool. Yeah, so the lower volt drop also means an increase in efficiency as there is less I squared R heat loss when we need to make it conduct. And yeah, it is faster. Cool. So I am going to go back to some of the questions that we missed off and just give you guys the answers. Cool. So this circuit, so we have our load, which is connected to, I assume this is our negative, and then we have our this is called right now. Cool. So with this, who can take a guess whereabouts we're going to put this variable this potentiometer to create this regulated variable voltage? Cool. So we're going to actually put it in parallel with our diode. So using that potentiometer, we'll be able to regulate a variable voltage from 0 to 12 volts. Because basically we are creating another path for the voltage to go through before it gets through to our gate up here. Cool. So I'll leave that up for a little bit so people can pause the video. It's not my day. Where was the next one? Cool. So an LM7805 is a fixed positive 5-volt voltage regulator. So using a potentiometer, it is possible to use this chip as a variable power supply. So how can this be achieved? By sketching a diagram with one LM7805, one 10K pot, and two 10 microfarad caps. So the data sheet for LM7805 may help you with this, so you can Google it. Cool. So we have our first capacitor here, 10 microfarads. We have our LM7805. We have our potentiometer here. And then we have our final capacitor here. Your positive side, 10 microfarads. Obviously, this is 10K. This is leg 1, leg 2, 3. And we have our output. So this is how you would draw that circuit. So this is how we use it as a variable power supply. So this potentiometer would tell the LM7805 how much voltage to allow through. Cool. And then the last question that we would have gone over is draw the circuit symbols for the following. Zener diode is what we had in that symbol we had before. It's a triangle, little wonky leg. LED is a diode and a circle with the arrows pointing towards the outside, showing that it creates light. A PNP transistor. An NPN transistor. Playing its fun games again. Diac. Then your SCR. That is how you would draw those symbols. Cool, guys, we've made it to 7 o'clock. So we'll call that class for tonight, unless anyone has any questions. Again, I'm technically paid for 3 hours. So if you have any questions relating to the topic, any questions relating to any other topic, or just questions in general, feel free to just pop the question up and then I'll deal with them as best I can. Otherwise, guys are welcome to log off. I will just quickly